In algebra, there is a very big concept that we're about to start covering, and that is slope. So the slope is the rate of change of a linear equation. So whenever we're talking about slope, we're going to be looking at our rate of change, which is going to be the change in the dependent variable over the change in the independent variable. So we have rate of change equals change in y over change in x. If we are looking at having two coordinates, each of the coordinates would have an x value and a y value, and we call those x1, y1 for the first one, and x2, y2 for the second one. If you have 2 points, it doesn't matter which one you name coordinate 1 and coordinate 2, as long as you keep the x and y values together. So x1 has to go with y1, x2 has to go with y2. So whenever we have these, the formula for slope is going to be m equals, and so to do the change, that's going to be subtraction. So we would have y2 minus y1 over x2 minus x1. So we're going to be dealing with slope for a long time in Algebra 1. So let's start off with a table, and we're going to use this to find a rate of change. So if we're wanting to find the rate of change, we're going to need to determine what our x value and our y values are. So independent variable here in this situation is going to be the number of computer games, and our dependent is going to be the total cost. So our x values are 2, 4, and 6, and our y values are as given. So whenever we want to find the slope, whenever we talked about that formula, we said we needed to choose two values. So in this table, for this example, we're choosing the coordinate 2, 78, and 4, 56. And so this will just be x1, y1, and x2, y2. And those are the points that we need for our coordinate. So we want to find the change in our cost, which will do 156 minus 78, and that will give us 78. And then our change in our number of games, so that'll be 4 minus 2, which will give us 2. So to find that rate of change, we have 78 as our change in the cost over 2 for our change in the games. And whenever we simplify that, we get 39 over 1, which means $39 for one game. So that's telling us the cost per game, and that's a rate of change. So here's this concept I was talking about, or the formula I was talking about, and we're not always given a table with descriptions. So like we had our video games and our floor tiles, sometimes we're just given coordinates or tables or graphs to find the slope. So if we're given 2 points, we're going to use this formula, and it's representing our rise, which is the change in y's, and our run. So you might hear rise over run for a graph. So now let's look at these three examples that have different coordinates that we're going to look at. And we're going to use these coordinates and plug those into our slope formula. So on this example A here, our coordinates are already named for us as x1, y1 for the first coordinate, and x2, y2 for the second one, so that we can just plug them into our formula. So the numerator of our formula is y2 minus y1, so that's going to be 5 minus 2. And for x2 minus x1, that's 5 minus negative 3. So I want you to be careful not to fall into the trap of trying to subtract within a coordinate. It always has to go from one coordinate of it to another because we're trying to find the change. So if I simplify this down, I get 3 over 8. So I'm going to get a slope of 3 over 8. So that means for each 3 that the y change, the x changes by 8. So for our next one, let's go in and label them. x1, y1, x2, y2. And plug these into my slope formula. So I'll have negative 8 minus negative 4 for my y's, and negative 2 minus negative 3 for my x's. So as I simplify these, I get negative 4 over 1. And that's going to simplify in this case because negative 4 over 1 is just negative 4. So we want to put it in simplest terms. So that will be negative 4. And for my last one, so I'm going to name these again, x1, y1, x2, y2, and then plug them into the formula. So on top, y2 minus y1, which will be 4 minus 4. And on the bottom, x2 minus x1, which is 4 minus negative 3. So when I simplify, I get 0 over 7, and this divides out to give me 0. So these are 3 of 4 of our types of slope. A had a positive slope, which means it is increasing. So if we were looking at a graph, it would be increasing from left to right. B had a slope of negative 4. So since it's a negative slope, that will be a decreasing slope, going down from left to right. And the last one is a 0 slope. And a 0 slope means that it has no rise and all run. So that's going to be a horizontal line. So we have positive, negative, and the 0 slope. So after we've looked at our positive, negative, and 0 slopes, the last kind of slope we need to talk about is the undefined slope. So an undefined slope, as we solve this down, we'll see what that means. So our process is the same. We're still looking at the change in our coordinates. So I'm going to label them x2 or x1, y1, x2, y2, so that I can plug them into the formula. So for y2 minus y1, I have negative 3 minus 4. And for x2 minus x1, that's negative 2 minus negative 2. So when I simplify this down, I have negative 7 divided by 0. So the big thing that happens here is that we have a 0 in the denominator, and remember that you can't divide by 0. To get a quotient, we have to have at least 1 under here, so we can't divide anything by 0. So whenever you have division by 0, this means it's all rise and no run. So this is what we call undefined. So if there's a 0 on the bottom, your slope is undefined, which means it's going to be a all rise, no run line. It's going to be a vertical line. So now we have these different types of slope. For a positive slope, we said that was increasing from left to right. So that's going to be a line that goes up from left to right. A negative slope that goes down from left to right. So a way that we can remember this is we can use the V in positive to see that increasing slope. We can use the inside of this N in negative to help us remember a negative slope goes down as you go from left to right. And then for a 0 slope, remember that was all run and no rise, so there was a 0 on top. It's a horizontal line like the top of the Z. And undefined, since that one was all rise and no run, that's going to be a vertical line, much like the side of the U. So we have positive, increasing, negative, decreasing, 0, which is a horizontal line, and undefined, which is a vertical line. So if we look at these two special types, the 0 and undefined, a 0 slope has a 0 on the top. That means that y is constant, so that it's all run, no rise. It's a 0 on top. For undefined, that's a 0 on the bottom, which means that your x is constant. So that's a way that you can kind of tell from the original question what kind of slope it's going to have. Notice in example 3, the x's match on the your turn and on the example.